Hello, my name is Michele Weber. I'm the Director of Conservation Innovation at Revive and Restore, and I'm going to be talking about intended consequences. The phrase intended consequences may sound vaguely familiar. Where have you heard that before? We'll get there in a few minutes. But first, this is a healthy, balanced, functional coral reef ecosystem, or at least it was 10 years ago when I took this picture. We know that corals build reef structures that provide habitat for a breathtaking diversity of marine organisms. Balanced functional coral reef ecosystems have supported remarkable biodiversity for millions of years. Many of us in the Reef Futures community are working to restore reefs, working towards this goal. If we ask the right questions, if we build sophisticated seawater systems, if we work hard enough, especially those late nights during spawning season, we can achieve our goals. The intended consequences of our work are healthy, balanced coral reefs. But intended consequences is about more than ambitious goals. It's about a tweak to the prevailing mindset. But before I get into that, I want to give you just a bit of the backstory. I work for a nonprofit called Revive and Restore, and we are bringing biotechnologies to conservation. We look out at degraded ecosystems. We want to restore them. We want to adapt biotechnologies to help restore coral reefs. We will need to tackle these pervasive biological threats. Restoration efforts are well underway around the world, really, and threatened populations are still plagued by these threats. The Florida panther got down to fewer than 30 individuals and faced severe repercussions from the bottleneck. New diseases like sylvatic plague on the American prairie or stony coral tissue loss disease, which was first reported in Florida, threaten taxa that haven't had the chance to evolve natural defenses yet. And then there are invasive species like this lionfish that's eating its way through the Caribbean. Against the terrifying backdrop of climate change, we also need to face these threats. We think that innovative biotechnology tools can be put to good use. We see biotechnologies that are locked up in industry or buried in an obscure corner in the ivory tower. It doesn't seem fair that the conservationists on the ground or in the water are the last people to get access to these transformational tools. They're in regular use in other fields like biomedicine and agriculture. We call this approach the Genetic Rescue Toolkit. It's organized with the ready-to-go foundational tools like genome sequencing across the bottom. And as you move up and to the right, the tools get more complicated and sophisticated with longer timelines before they can be applied. But we all know that building tools is challenging. Even in the face of climate change and these other threats, funding is hard to get, grants are hard to get. The science is also challenging. Reefs are complex systems, and corals are whole ecosystems themselves with symbionts and other associated microbial communities. But the social dynamic can get complicated too. People can be hesitant to embrace intervention. When you get to the point of manipulating corals, whether you want to translocate them or develop a new genetic tool, you hear a few familiar questions. Are you playing God? What could possibly go wrong? That one's always sarcastic. And what about the unintended consequences? I bet that sounds familiar to a lot of people. We are using the phrase intended consequences as a deliberate counterweight to address the reflexive questions and to offer productive alternatives. Intended consequences advocates for keeping an eye on positive outcomes, the benefits to biodiversity, and working toward a future we want. Earlier this year, we put out a special issue on intended consequences. Authors weighed in on this idea from diverse disciplinary perspectives. And intended consequences includes many different themes. These are just 4 of my favorite reminders. When you are talking about conservation interventions, diverse values matter. Ethical, inclusive engagement is absolutely crucial. Inaction is also a choice, and it also has consequences. And finally, interventions can and do benefit nature. This is where I ask you to tweak your mindset just a little bit. When you get bogged down by concerns about unintended consequences, or when you hear other people wrestling with this question, think about the counterweight. Remember these themes and consider your intended consequences. So let's start with values matter. We've learned that values play a major role in decision-making, especially in conservation where they intersect with many different questions. For example, which baseline are you trying to restore to and why? Are you committed to genetic purity? How do you approach the blurry lines that come up when we talk about hybridization strategies? And finally, how do you feel about naturalness and wildness? What about wilderness? These are just two of the papers that were part of the special issue that take on these difficult values questions. So if we identify a problem, a solution, and hopefully we're working towards demonstrating proof of concept, where do we incorporate the values conversations? People are trying different strategies with respect to the process, but what we all agree on is that inclusivity is absolutely crucial. So third theme, inaction has consequences. It's also a choice, and that choice has consequences. Reefs around the world are degraded, and there are still many unanswered questions, but we must weigh the risks against the benefits. And when I look at the status of coral reefs of the world, the latest version from 2020 that just came out in the last month or so, inaction feels risky for coral reefs. Finally, number 4, interventions can benefit nature. Perhaps this seems obvious to this crowd, but we wrote a paper showing that there have been over 1,000 terrestrial taxa translocated within the US. Overwhelmingly, these interventions achieved their intended consequences. And really, it's just a few horror stories from other fields at that create confusion and hesitancy. There's much more to that story, and I encourage you to look it up. It's open access on the SCB website. And with respect to coral reefs, we've learned so much about intervention. We've learned how coral reefs function, how corals themselves function, how the associated organisms function. We've learned a lot about how to design NPAs, how to grow corals and outplant them to fortify degraded reefs. And we know that a lot of times these interventions do work. Reefs around the world are degraded. These incredible ecosystems are certainly complicated, and there are still many unanswered questions. But if we wait too long, we lose these ecosystems and we lose the chance to answer those questions. I think inaction is risky. So what do we need to do? Well, maybe we need to consider that intervention can be part of the solution. Responsible interventions can transform threatened ecosystems into recovering ecosystems, characterized by abundance, biodiversity, and resilience. So what tools do we need? We need to protect marine regions. Translocation and reintroduction, these tools have been very successful in terrestrial conservation practice, and we're learning to use them to help reefs as well. And what about genetic rescue? We envision a suite of genetic rescue tools specifically for coral reefs. Inspired by intended consequences, scientists are starting to build the tools that we need. Things like genomics, biobanking, microbiome, stem cells, and maybe even genetic engineering. Here are just 4 scientists on the front lines of tool development. Dan Bartis is working on the mechanics of coral climate change, resilience, and susceptibility. He is sequencing the genomes of mesophotic corals to see how they are different from shallow water corals that experience bigger temperature swings. Mary Hagedorn is developing new methods to cryopreserve coral reef biodiversity. She's working with different coral tissue types and trying different technologies, new technologies from other fields to make sure that we have living coral tissues frozen down. Blake Ushijima is using high-tech equipment to scale up his method for discovering beneficial bacteria that can help protect corals. And in the process, he's hoping to finally identify that pesky pathogen that causes stony coral tissue loss disease. Nikki and Benjamin are isolating and characterizing coral stem cells, which can potentially be developed into tools for coral restoration. To achieve intended consequences, we need to explore all of these tools. The 4 projects I just mentioned and a handful more are part of our Advanced Coral Toolkit. You can learn more about this on our website if you're interested. We need to solve climate change. And in the meantime, let's explore these new biotechnology capabilities, add them to our repertoire, develop new tools. This will help increase our chances of achieving intended consequences so that we have balanced, functional coral reefs for future generations. Thank you.